We will Today we'll talk about the fundamentals and the introduction to this microelectronics course. So just to explain a little bit of an introduction. So the course will follow this textbook. Um, the textbook is Sedra and Smith. Um, it's called a microelectronics circuit. And usually this textbook, it explains things pretty well. It's pretty straightforward, and the explanations are very simple, and they're a little bit easier to understand. And Sedra and Smith, the notation for some variables and constants remains pretty consistent. But occasionally, there is another textbook that I have found it's also very helpful. Is this Bezad Razavi. So he has a textbook on the fundamentals of microelectronics, and he also has another book called Design of CMOS Integrated Circuits. And I think Razavi, his explanations are a little bit more advanced, but I think, sometimes Sedra Smith, if it doesn't explain something that well, occasionally I will quote from Razavi or use some of his graphs and the equations. But usually I follow along Sedra Smith because it's a little bit more simpler. But if I need a more advanced example, I look at Bezad Razavi. And also there's another one. There's a Philip Allen. And Philip Allen has a CMOS analog circuit design. And this textbook, it focuses more on how do we design certain different kinds of circuits. And sometimes I use this textbook as well. But mainly the focus right here is Sedra and Smith. So what are some topics that this textbook, Sedra and Smith textbook, talks about? Okay, so the first main section is the basic circuits. And basic circuits, first we talk about signals. So signals are information that get carried over time. So we will be working with electronic signals. And one thing about signals is you can do the amplification. So we will look at amplifiers. And one type of amplifier, there's many different kinds, but one type is op-amps. And so this is the first kind of device that we will study in this course. It's called the op-amps. And op-amps is a little bit different kind of amplifier. What it does is it looks at the voltage difference of two inputs and then it amplifies the difference. So we'll learn about op-amps. But there's also some other topics that come after that. There's a topic on diodes, and then there's a topic on BJT, which is a type of transistor, and then there's a topic on the MOSFET, which is the modern kind of transistor. And so usually they cover this topic in second and third year of the undergrad. So there are also a couple other topics in this textbook. Usually after you learn these basic circuits, the next section of the textbook is called analog signals and amplifiers. And so some examples of this would be, there are some basic amplifiers that are MOSFETs can be arranged in certain ways called basic amplifiers, and these are used all the time. And so they're frequently used configurations of MOSFET. And also there's multi-stage amplifiers. And there's differential amplifiers. So there's a lot of different topics talking about many different kind of amplifiers. And usually this would be I would say like end of the third year or maybe fourth year of the undergrad. And there's also a shorter section about digital circuits. So digital is you can use MOSFETs to design the circuits that are the computing that is used in modern times. They call that CMOS. So CMOS is a combination of a PMOS type circuit and a N type the MOSFET put together. They can make different logic gates. And there's also memory. So these are different topics, and these are usually pretty advanced. Maybe I would say fourth year of the undergrad, maybe third year. And then there's also advanced topics, and these are things like filters and oscillators and advanced amplifiers. And these can be made with MOSFETs, they can be op amps, and a lot of things. And there's also op amp design. So we begin learning about microelectronics. The first device that we learn about is op amp, but we only learn how to use it. And then in the advanced course, we actually learn how to design the op amp using the BJTs and the MOSFET. And this is probably, I would say, maybe like filters and oscillators are third year, but maybe this is fourth year, or maybe grad level course if you're doing the op amp design. So let's talk about why do we learn all these different things? Because the motivation. Okay, so the motivation is that it's electrical engineering. This is a core course. It's the fundamentals, and we also can learn about the innovation. So there's innovative applications of these chips. And also, so what do we need to learn about these different topics? Well, there's some prerequisites that we need. Prerequisites. And you need to know about the basic circuit theory. And so you need to know the KCL and the KVL, Ohm's law, and there's a Thevenin, and there's also the Norton theories. And so like basic network analysis, that's probably a good prerequisite for this course.